So what we want to try and do is convert this into the line angle.
Okay.
So there's two approaches that we can go to doing this. Or there's probably more than that, but this is how I would do it. We're going to grab this front carbon, and we have two directions we can pull it. We can either pull it to the right, which I'll show first, or we could pull that carbon to the left. Okay, and I'll color code those. Okay. So I'm going to add some extra colors on this too. We'll call our front carbon orange, and we'll call our back carbon green. Okay. So if we look at our right direction, if we pull that front carbon to the right, where should our orange carbon be? Left or right?
Right.
Yep. Where would our green carbon be then?
Left.
On the left. Right, and now we'll color code the rest with lines. Those two would be connected to each other.
Okay.
Where is this CH3? What atom is it attached to? It's attached to the orange. Where is it? Above or below?
Above.
Above. And as we pull it across, where does it aim?
Oh, towards us.
Yes.
Towards you. So we would go through and put that as a wedge with a CH3. What about this CH3?
I had a hard time with that too.
It stays in the front.
And below.
I just wrote them down and just trying to.
What happens with our CH2, CH3?
Away and above.
Right. And we go to our green carbon. Where's our chlorine?
Above and in the front.
And our hydrogens?
Yeah.
One's
And then he
below.
gave me
They're both below, and one's forward and
as far
one's
as
back.
a couple others.
I want to write those down too.
Oh yeah.
There we go.
Oh.
So these are all the deactivators?
Do you want me to look at the blue
These
one?
are activators?
Yeah.
No.
Okay. Then we'll just stick with that. So that's all that you're ultimately trying to do.
Okay.
And if you did the blue one, it's the same idea, except now your orange atom would be on the left side of the green one.
Which number?
Okay.
And you just have to make sure you account for each of those six where they're going.
Okay.
Yep.
Let's see. I'll put that. Yeah.
What you've asked me to do
They
is try
won't
and
share.
convert
They just
this
want it.
into an overhead view, ultimately a chair too. So we'll kind of work with it and see what we can do. So to get the overhead view, the first thing I would do is it's how many carbons are in
So
there?
then,
1, 2, 3, 4, 5, 6.
6. So 6 carbons in a ring.
carbon.
Ta-da! Where is this?
Because it has one hydrogen, right?
Carbon?
Yeah. So
Straight
then
up?
it's an activator.
Okay, so it's coming straight up. To get this overhead view, we had to come in
Explain to me
and
the
look
big,
at this
long
structure
process of one of these.
from this
What
direction.
is
That
that?
looks kind
Is
of
that a
over.
test?
Make sure
No,
that looks
it's
like an eyeball.
14.
Okay, so that's an eye
This
looking
looks
down.
like the big,
Okay.
long
Where's that
process of
CH3
it.
in?
No.
At the eye,
Where's the
away from
answers
you.
to it?
Okay.
At the eye, which would mean
Yeah, I actually
if something's coming at you, how do we show it?
To understand
Wedge?
the whole thing.
I just don't get it.
Yeah.
There you go. You now have the overhead view.
No.
Done.
Oh.
Let me find my.
Okay.
Okay. So, and if we add other things onto it, so if we added a CH3, let's make this one a CH3 now.
Okay.
Where's that CH3?
Are you tutoring?
Away from you on this guy.
So we got to be very careful on where we're looking. That carbon is connected to this circle in back, which happens to be connected to
Oh, so it's the same
the
carbon.
same carbon. That was unintentional. I didn't mean to bond it to that, but that's what I did.
So if
My
it
girls are like.
so if it were just the one, it could be representative of any of the carbons.
Yes.
Okay. So then how do you determine, because the question asks axial versus equatorial. I can get gauche versus ANSI, but I don't understand the equatorial axial.
So axial is aimed up and down above the ring. Equatorial is aimed away from the ring.
So if it's a wedge, it's
So now you have that
axial.
whole
If it's
thing.
a dash, it's
Yeah,
Oh, there we
you
go.
can't. I mean, that kind of works in this example, but it doesn't quite always work that way.
So basically,
Because
you
if
take
I go
that
through
so the whole thing is attached. Now you're gonna
and I
probably
make
wanna draw it out,
this,
so you
look at
really
this
see
blue
the
hydrogen,
bonds.
would that be axial or equatorial?
Axial.
According to your definition, it would absolutely be axial.
Oh,
It's
okay.
equatorial.
Yeah.
Okay.
You gotta remember.
So
take off that
what you need to, or for me, the easiest thing to evaluate when we're looking at our axials is it's this
I know
direction.
we
Anything in that plane, when we're looking at our our Newman projection, in that up-down is axial.
So this is
Where's So when we look at the axials, again,
Taiwan, yeah.
if we were going to label them,
So that's really
oops,
two
I'm
different
going to have to
structures
change this
that I kind of
hydrogen.
put into one, and that's
Get that color coding fixed. So the axials that we could see
And then you have your NO2.
would be anything going up and down. These are all our axial positions. And if we were going to do our equatorial, the equatorial
Or step. That makes a positive
whatever.
rotary.
is going to be anything that's not
Gonna be
going
at
straight
the
up and
meta
down.
position.
So equatorial, equatorial, equatorial,
Let's write
and
that down.
equatorial.
Okay.
So does that mean that
And again, we can't conclude anything about the middle ones, at least how they're drawn. Those we can't conclude unless we turn the structure and looked at a new Newman projection. That involves a whole lot more drawing, probably doing.
Understand why it
Okay.
goes here, but we're
Sound good?
the arrow there. You always take your electron.